Welcome to Industrial PLC Applications. This video is the Introduction to Programmable Logic Controllers, Part 1, Relays and Relay Logic. After completing this video series, you should be able to define automation, discuss the different methods of machine and process control, identify relay logic controlled automation, and identify PLC controlled automation. Let's begin by defining what we mean by automation. Automation is a method of operating or controlling a process by highly automatic means via electronic devices, thereby reducing human intervention to a minimum. Automated systems function automatically without continuous input from an operator. Some of the basic automation variables that can be controlled are speed, like that of a conveyor, volume and flow, gallons per minute, temperature of liquids, solids, ovens, etc. Time. You want something to happen for a period of time before you move on to the next step. Production volumes. How many things have we made? To understand modern automation, we must take a quick look at the first generation of automation, electrical relays and relay logic. Relays are electromechanical devices that act as controllable switches. The first electrical relay was invented in 1835 by Joseph Henry. Originally intended for an improved telegraph system, it was quickly adopted for manufacturing automation once cheap electrical power became available. Relays allowed automation to expand the capability and efficiency of machinery, since they removed the necessity of manually energizing or de-energizing circuits and created a method of counting or storing data. Over time, relays became smaller and more efficient. More contacts were added, providing better monitoring and control. Let's begin by looking at the relay itself. First of all, it has a coil which, when energized, creates an electromagnet that pulls on the armature. The armature, which then moves backwards and forwards, pushes the electrical contact closed or open. The electrical contacts, which are forced closed or open, pass electrical power to another part of the automation or machinery. When dealing with relay logic, it's important to keep this key term in mind: shelf state. Shelf state is the condition of an electrical device when it is not active or not energized. It's basically right out of the box or off the shelf. Contacts have two distinct conditions: normally open, which will not pass power until the relay is energized, and normally closed, which passes power until they are open when the relay is energized. When current is applied to the coil of the relay, a strong magnetic field pulls the armature to the magnet. The contacts are mechanically linked to the armature and are forced to change state. When the relay is de-energized, a spring is used to pull the armature back to its shelf state. The key concept to remember here is that when the relay is turned on, the normally open contacts close and the normally closed contacts open. But automation required more than just automatic switches, so specialty relays such as timers and counters were developed to further the automation process. This led to the development of relay logic and relay logic schematics. Each device or function is represented by a unique symbol shown in its logical position of flow. Every device is shown in its shelf state and are referenced by rung and rung position. For example, the float switch is on rung 110, and it's the second device position, hence its number is 1102. One of the drawbacks of electrical relays is they consume a great deal of power and are prone to burnout or mechanical failure after protracted use. Furthermore, the control system itself can create a great deal of heat due to the physical size and current draw of the components. In large applications, several cabinets are often required and can be very difficult to troubleshoot. Although quite reliable, once installed and running, relay automation isn't very flexible or easily modified. To make changes to the operation of a process means the purchasing of components like relays, solenoids, timers, and counters, and then manually rewiring and testing of the new design. In our next video, we're going to look at programmable logic controllers and PLC logic.